Hello Math 8, this is lesson 3.2, using models to multiply fractions. Just going to get you to recall something. Remember that 3 over 1, that fraction is 3 split into one group, would have 3 in each group, right? So 3 over 1 is the same thing as 3. So if I write something here, if I write a question like we did last time, where it's 3 times 1/3, we could just use repeating addition, where we take that fraction and we repeat it how many times? We add it 3 times, 1, 2, 3, and 1 plus 1 plus 1 is 3 over that same denominator, 3 over 3, anything divided by itself is 1. Or we can use this method here that I'm just going to move down. There's 2 steps to it. The first one is to multiply your numerators, and that is what your new numerator will be, so 3 times 1 is 1. And then you will multiply your denominators, is our second step, which is 1 times 3, which is 3. 3 over 3 is 1. That's what I call the quick trick. Now, just note that these are actually the same thing. Why? Because 3 over 1 is the same thing as 3. So these are actually equivalent sort of expressions as an equation. So notice that you got the same value. It's because this is actually the same as this. It's just you've made it into a fraction. Now what we did last time was when we had a whole number multiplied by a fraction. Today we're going to be doing it where we have fraction times a fraction. We're going to do a few examples, and these examples will illustrate this quick trick that I've shown you here. The reason why we want to know the quick trick is because it's fast to do, but the disadvantage of the quick trick is that sometimes we don't quite understand why it's there, and then we're not able to apply it into a real world problem. So these models will help us do that. Before we get there, I want to just go over a common misconception, something that people often get mixed up with this. Remember last year when in grade 7 you would have been learning about adding fractions and subtracting fractions, how you had to always get a common denominator, so the bottom always had to be the same. With multiplying and dividing fractions, it doesn't require common denominators. So a common thing that people do in this unit, and that kind of shows me that you're good at doing like a process, but you don't actually understand why you're doing the process, it comes here. I'm just going to show you there's the same question twice. We're going to do it twice here. Let's just draw a line down the middle so we're not confused. The left is someone who might not understand why they're doing something or when to do something, whereas the right side is maybe the quicker way. You'll notice by understanding why to do it, it's going to be less steps. So here, someone saw fractions and they thought, oh, I need common denominator, and yet they don't. It doesn't require it. They took their third and they realized that 3 could turn into 6 by multiplying by 2, so they also multiplied the top by 2 to make an equivalent fraction, 2/6, and then they multiplied the numerators and multiplied the denominator and got 2 times 2 is 4, 6 times 6 is 36, and then they divided by 4 on both sides, and 4 divided by 4 is 1, and 36 divided by 4 is 9. So they got 1/9 is what 2/6 times 1/3 was. Now this took a few steps. This way over here, someone who realizes this is an addition and subtraction, this is multiplying right here, and it also applies to dividing, you don't need to come up with a common denominator. You can just straight up skip to these 2 steps right here, multiply numerators and multiply denominators. So 2 times 1 is 2, 6 times 3 is 18, and then realize those are both even numbers, they can both divide by 2, and it's 1/9. See how it takes less steps, and it still gets you to the same answer, which means you've still done it correctly. So let's look at an example here. It says Terry cuts 1/3 of the lawn, Gretchen cuts 1/2 of what is left uncut. What fraction of the entire lawn, the whole thing, did Gretchen cut? So here we're going to use a little model. Let's draw out the field. And I decided to pick the width, something that both of the denominators could divide by, and then the height, I just chose one of them. There was one that could divide by. So I chose 6 wide by 4, and it worked out. So the whole lawn is circled in blue here. So the entire lawn is blue. And it says Terry cuts 1/3 of that entire lawn. So if you split it up into thirds, 3 equal pieces, Terry cuts that 1/3. Then it says here that Gretchen cuts 1/2 of what is left uncut by Terry, right? So we're not talking about this part, we're just talking about this. And what is half of it? It's this piece right here, 8 pieces, and then there's 8 pieces here, so it's half of them, right? So that's what Gretchen cut. Now the question asks, what fraction of the entire lawn, this whole thing, did Gretchen cut? Well, looking here, it's 1 piece out of the 3, right? So with this model, we found out that it's actually 1/3 that Gretchen cut. Now a mathematical way to show this, and remember, always, if there's a question mark, question asked, always write a statement to answer it. A mathematical way to show this would be that the entire lawn is 1. Terry cut 1/3 of it, so we're not talking about that third. That's what's left uncut, right? It's the 2/3 is what's left uncut. And 2/3 times that 1/2 of Gretchen's is what will get you how much Gretchen actually cut. And if you go 2 times 1, it's 2. 3 times 2 is 6. 2 and 6 can both divide by 2, and we're left with 1/3. And we end up getting to that same answer. Our second example is 2/3 times 6/8. Now, we could apply our method here, but we're going to maybe use counters instead. So what you do here is remember that 2/3 times 6/8 means 2/3 of 6/8. So whichever of your fractions has the larger denominator, that's the one that you're going to count out that many dots, that many counters. So I counted out 1, 2, 3, 4, 5, 6, 7, 8 counters. And then I put a box around what my numerator was. I put it around 6 of those 8 counters. Okay? Now it's asking what's 2/3 of that 6/8. So 2/3 of that 6/8. So if we split into thirds, 1/3, 2/3, and 3/3, we have 1/3 here, 2/3, and 3/3. We're talking about 2/3. It'd be this and this would be our 2/3. So I circled that in green. And if we count that, 2/3 of 6/8, now how much is this of the 8 pieces? Well, 2/3 of the 6 is 4 of the 8. So we found out that it's 4/8, which if we look at that, 4 divided by 4, 8 divided by 4, they both divide by 4, we can make an equivalent fraction of 1/2. So we find out that 2/3 of 6/8 is actually 1/2 of the 8. That would make up the whole thing. So perhaps this was a whole chocolate bar. Someone had eaten 2 pieces in the past. There's 6 left over, and someone's like, I want 2/3 of those 6 pieces. How much chocolate bars do they eat? They ate half of the entire chocolate bar. So here, just to check that we did our work right, let's use that method. 2 times 6 is 12. 3 times 8 is 24. 12 and 24 can both divide by 12. And because 24 is twice as big as 12, 12 becomes 1, and 24 becomes 2. And we end up with 1/2, which is that answer that we had before. Here's our example 3. It says half of the students the grade 8 students, tried out for the school flying disc team or ultimate frisbee team. Frisbee's a brand name. They're technically called flying discs. Fun fact. So half tried out. 3/4 of those who tried out were successful. What fraction of the grade 8s made the team? So what I did here was I looked at my denominators and I decided to make a box here. So I'm using a rectangle to try to solve this problem. And I made the width one of the denominators and the height the other denominator. So this is half, and this would be half. This would be a quarter, a quarter, a quarter, a quarter. So if this is all the students in grade 8 represented here, I'm going to look here and it says half the students tried out for the flying disc team. So I'm going to shade in half of the students, and those are the ones that tried out for the team. Okay? Here are the half that tried out for the team. And then it says that 3/4 of the ones that tried out, they were successful. So I'm now going to take, I split it horizontally. Now I'm going to split it vertically, 3/4 of this. I'm going to take all the students and I'm going to take 3/4 and I'm going to draw some lines through. But only of what is left. Okay, so I draw through these ones here. Or I could have done it even another way, but this is the way that the textbook shows. I'm looking at the ones that are both part of the half that tried out and are part of the 3/4 that made the team. Which ones have both the gray shading and the red lines? Well, it's these three right here. This 1, 2, and 3. Let me use a different color for that. Let's use purple. 1, 2, and 3. It's those three. Now looking there, of these pieces here, there's 3, and how many pieces of that same size are in the whole class here? Well, there's 8 of those pieces, so our answer would be 3/8. Now to check this, we're talking 3/4 of a half. 3 of a half means 3/4 times a half, or a half times 3/4. The order doesn't matter. 1 times 3 is 3. 2 times 4 is 8. And we got 3/8. Therefore, 3/8 of the grade 8s made the team. So if there were 8 students in the class, 3 would have made the team. That'd be small ultimate frisbee team and also a small class. Now there's kind of 2 ways that people do these models, and I'm just going to show this here. How I actually learned to do this was I actually shaded all of this in. I actually shaded in 3/4 of the square, and then the other dimension I ended up shading in half. And then it was just the ones here that we're looking at that were shaded in that would count. Now, our textbook, I think some of the examples you have, they're only going to shade in 3/4 of what was shaded before, and so you just look at the ones that are there. You still end up at the same answer. You'd still be looking at the ones that are both gray and the red stripes, or both striped, and there's different colors in the textbook that sometimes get used as well. And there you have it. That's lesson 3.2.